Okay. So what I would do, what I would look at this and say, good, width and that. So here's the first thing, create box width, height, and length. So the first is the X, Y, and Z. So clearly it's not this shape at all. It's actually drawn perpendicular to the X-axis. This is the shape here. Good. It's longer rather than it is wide, so it's that kind of shape there, right? It's the first thing. So that's creating the box. And this here controls the width of it. Okay, then the next thing. First of all, the offset. So this is going to be the offset for the first wheel. So I'm taking width divided by 2 minus the wheel radius for the X. Cool. Okay, so width divided by 2, and it's going to be minus the width divided by 2. So which wheel am I dealing with? Either one of these two wheels here, because it's width divided by 2, so it's going to be over this way on the X. And then I'm also taking minus the wheel radius. Okay, so that's width divided by 2. That's minus width divided by 2 at that point there, isn't it? And then I actually take width divided by 2 and I minus the radius from it, so I actually move over a bit here. And that's the wheel radius, so it's going to be half there, right? So say there. Then I take 0 on the Y, so that's going to be there on the Y. And then the length divided by 2 minus the length divided by 2 plus the wheel offset. Alright, so the length divided by 2 is going to be that. And then I add the wheel offset to it. So that's going to add, sorry, this way. So it's this wheel I'm talking about, is that right? For the first one?
Yeah.
Am I right?
Yeah.
So it's minus, sorry, maybe I'm wrong.
It's 1 by 2 minus on the Z.
Let me have a quick look. So it's minus the length divided by 2. So that's minus the length. So when I add the offset to it, this is the minus. So it's actually, sorry, it's the top wheel I'm talking about here. Am I right? I'll make sure. Is everybody clear on that one? So it's minus the length plus the wheel offset. Now length divided by 2 is going to be that. Oh yeah, plus the wheel offset. So it's minus that. So it's basically going to move it up here a little bit. Isn't that right?
Because it's like
that's the first wheel that I'm talking about there. I think so. The wheel offset is how far, so I'm taking length divided by 2 is going to be that distance there, and I'm subtracting it, so it's going to bring me more in the Z-axis. And then I'm also going to subtract the wheel offset, which is another 2 units off in this direction. And that's how I calculate that initial position for that wheel. Then I call create cylinder wheel radius. Now here's the interesting one, right, okay? So I take the position, which is the position of this thing, the center, and then I add the offset to it, which is this distance here, and that's how I can calculate everything relative to the center of the object. And the last parameter I pass in is the cube. Look at the quaternion. So what's the significance of passing that quaternion in?
turns it to left.
That is a 90-degree rotation around the x-axis. So if you take the cylinder and you rotate it 90 degrees, let's imagine the saucer section here is the cylinder. We take this and we rotate it 90 degrees around the x-axis, you basically get the wheel being up like this. So that's why, and that's because the cylinder in Bullet and the cylinder in BGE by default with no rotation is this type of cylinder, right? So that's why that parameter is set there. And so then I make this hinge constraint. Maybe I'll just bring up some notes to show you constraints, right? But basically, there's about 5 different types of constraints that Bullet can make. And these constrain objects to move relative to other objects. And then you specify various different parameters to configure those constraints. This is a hinge constraint. A hinge constraint is something that can just rotate, makes the object rotate around one axis of rotation. And you might wonder, why is a wheel rotating around a car a hinge constraint? And that's because the wheel is rotating around one axis, so it's the right type of constraint to use for something when you want something to move around one axis.
Can you make that do 2 axes?
What's that?
Can you make a hinge joint do 2 axes? I know in the real world you can't make it do more than one. But
Yeah,
can you do
kind
it?
of. We'll play with the parameters and see what happens.
Because I was trying to get it to work yesterday and I couldn't really work out what it was doing, and I was trying to get it to go like that and like that.
Yeah, I think what you can do is you can specify one of the axes, for example, to move this way, and the other axis to move this way, and then that's basically, they're both rotating around different axes relative to each other. Yeah, definitely. You can, definitely, 100%, I know that. I'll show you a bit of code to do that in a minute. So then GL to VT vector, offset, and then I'm passing in this parameter here, 0, 0, 0. The first rigid body that you pass in here is the chassis, and the second rigid body is the wheel. the first parameter that you pass in is the offset on the chassis, and the second parameter you pass is the offset relative to the local position of the wheel. So this is offset. So this is basically, these are called the anchor points. I think technically these anchor points, from what I understand, I think it's better if you guys are making these, if you make them off the objects rather than in the objects. This first parameter I've specified is actually the center point of the wheel relative to the chassis. And then the second parameter I pass in is 0, 0, 0, which is also the center point of the wheel relative to itself. So its own center point, its own local space center point is 0, 0, 0. Even though they're both inside the wheel, it seems to still work. So that's okay. And then the two axes of rotation, these are interesting because these are not what you think they're going to be. You notice I'm passing in 0, 0, 1, which is the z-axis on one of them. Now, the z-axis is correct if you think of the chassis, right? That's the z-axis for the chassis, and that is the axis by which you want to rotate.
But because you've rotated the wheel now, its local Z is different, right?
It's actually, yeah, its local Z is its local Z before the rotation. So for this one, and this took me a while to figure out, but it's kind of, when you think about it, it's obvious, right? This doesn't know the cylinder has been rotated. So this is the axis of rotation for a cylinder, which is this way. The default for a cylinder is this way, okay? So the axis of rotation you have to specify is 0, 1, 0. It's the y-axis. Because the cylinder in local space is like this. No, it's the y-axis. Like if you notice, the second parameter is the y-axis. So you pass it in the local orientation of the cylinder, and then when you rotate the cylinder, its axis will rotate, which you pass at 0, 1, 0, 1, 0. Does that make sense? That took me a while to figure out. I mean, I was setting this to be the same. I was thinking, why they should be the same axis? This should be 0. This should be 1, 0, 0 in both cases, but it's not, because the cylinder is rotated. You specify the local orientation of the cylinder. And then I think you always pass in true for that. I'm not quite sure what the last parameter signifies.
And is there a way you could actually call the local axis instead of handing in like you're handing in the global axis there and telling it to rotate around that because you know it's changed. So could you call that cylinder's local axis and rotate around that?
Probably could, yeah.
But I think
maybe not.
I should have
Just like immediately I thought about it and I thought no, I thought yes, but then immediately afterwards I'm thinking probably not. I think you just have to know that a cylinder by default is this. It's a flat cylinder like an oil barrel, and then your axis of rotation is relative to that. And you just rotate the cylinder before you when you're creating the cylinder, and then that's it. That's what you do.
Right here, it works because you know everything's at a 90-degree angle. You know exactly what the axes are going to be beforehand, so you can hard code it. So if you weren't hard coding this and you were trying to set up a rotation around an axis, it would be much trickier.
Depends on what axis you want to rotate around. It depends on what type of machine you're making. Most of the times, the axis of rotation are going to be fixed. Like if you were making, so it depends again on your type of machine. Depends on what you're making. But that's why you have to draw out first, I think, and then you can also consider what the local orientations of all of the things are, and then you can do everything relative to that. So, like I say, when I made this, I think a good strategy for you guys is to write something like this method here that creates all the rigid bodies in their positions, does not add any constraints to them, and then turn gravity off in the simulation and make sure everything stays in the correct place. And then once everything stays in the correct place, you can see what the initial positions for everything are, and are they the correct initial positions. Then after that, then add the constraints, make sure everything still doesn't move, and then after that, that's it, turn gravity on, turn your motors on and stuff like that, and the thing should walk or whatever. So that's how the car works.
With the constraints, making your rigid body move, will that be down to your ones and zeros and vector truths?
Yeah. The constraint, making the rigid body move, sorry, is that what you're asking?
Yeah, like if you put like, you've got your car, your wheel or whatever,
sure.
And there's no constraint, gravity's off and it sits perfectly, then you put a constraint on and it starts happening. What's I know there's a million and one problem.
Ask the question again. Say I make all the
What
rigid
part of the hinge constraint makes it move?
Oh, yeah. What you can do then is you can add what's called an angular motor to the hinge constraint, right? So, like, I'll just show you this one here. This is my physics factory. This is my physics game 1. This
Actually,
is
just before you go off that, Brian.
Sure.
The
No worries, yeah.
hinge constraints when you make, right? If you send in the second vector, the second set of vector trees of zeros, it breaks the whole thing.
Oh, yeah, because that's not an axis then.
I'm just saying, don't rotate at all. It's here's an axis, but don't do anything.
How is it a hinge joint then? It has to have an axis.
There's a fixed joint, isn't there?
There is a thing called a fixed joint, yeah. You don't pass in an axis. You don't have to pass in the axis for a fixed joint. I have examples of every single one of these joints, even ones with limits and stuff that I did today, so we can go through them, yeah? That's those ones. Yeah, so over here I just have a little thing called physics game 1, just to show you what that looks like, right? I'm going to call physics factory, and I'll turn gravity off here, okay? So then I can call physics factory create vehicle. Create vehicle, and I'm just going to pass in GLM call vec3. So I'll pass in, what's the previous one? Let's say pass in 10, 10, and 10. Okay, so I'm going to create the vehicle in that. The moment the constraints are turned off on that vehicle, I create them, but I don't add them to the scene. So when you go to run it, you should just get the vehicle hovering in space. There's no constraints, but that's the initial positions of everything set correctly. And then, just to show you, there's no constraints on these objects. So they're not attached to each other yet. Or maybe that last one must be attached, because it seems like it is attached. But you see, they're pretty much most of the other ones, they're not attached. So that's what you want yours to do. You want yours to not move, and everything be in its initial starting position. So, in the physics factory, then, I've added one constraint. So then you add all the constraints, and still up in the air. So then, shift control B to build it. I'm actually just going to leave that off for a second, right? Because that's the angular motor. Just asking how to make something move. So now it's all there, and all of the joints are attached to the object and specified correctly. So when I move one bit of it, they're all going to try and stay in the same relative positions. And the last thing I might want to do is turn gravity on in this. So I just set the gravity to be -9, and then when I go and run this, you'll be able to see that those wheels will be able to rotate around the chassis. So I'll go there like that, and if I just to give it a little bit of a shove like this, you'll see that the wheels now are able to rotate, and that's the constraint, that's the hinge joint constraint on.
They rotate relative to the ground.
Exactly.
They're rotating. They go like
The
this.
back one looks a bit loose.
It shouldn't happen.
Is that what's happening?
It's like,
I actually don't know. I'm not too sure. Sometimes the joints are not. I think it's just there must be something you can specify in the joints how strict they are, because things are allowed to go out. Like here's an example. Okay. Here's the other bit gone. There we go. Here's an interesting thing here. Maybe you guys can figure this one out. Okay, look at what's able to happen here. So if I let it bounce all the way over to there, and then it will bounce back. Now that's a hinge joint. Why is it doing that? I do not know. There must be something that you can specify about the tightness of the constraints. Because that's a hinge joint. What's the axis of rotation for that hinge joint?
up, yeah.
It's the up axis. And look what I've done on this one. Even though Dean told me they don't work, the first time I tried it, they just worked. Because they'll go all the way to the right, all the way over here. I'll fire something at it. It'll go to there, and then it comes all the way back again. He's not asking why it's doing that, but that ain't supposed to happen.
Yeah, that's wrong.
I'm just trying to give it a bounce. Look what happens. Stops. So that's a limit on the joint. And that just worked. I don't know. I don't know what the big deal was. It's
one that's not moving, because that's a static.
Yeah, great. The one that's not moving is static.
So, that would only be something like this.
I don't know. I'm not really sure. Look at this. This is how you make a static object, okay? You can call the physics factory and you can create your object, make it not a kinematic object, but after you get the rigid body back, you just call set mass properties, set it to be 0, and then the second parameter is the inertial tensor, so you set it to be 0. Then the object's mass is 0, and it becomes a static object, and it will never move. So that's one of the objects is static, and it's kind of cool when you're testing out joints to make one of them static and the other one dynamic. And then here is the interesting thing. This is where I'm setting the limits. So it seems when I created the limits on this joint, and you guys can experiment with yourselves, I made these two things like this. I made one rigid body like that, and I made one rigid body like that. When I set the limit to be 0 for both of them, they won't move at all. Okay, so this appears to be 0 radians here. That's 0. See, so that's your 0 radians. The next thing then, this is positive pi over 2 radians, and this is negative pi over 2 radians, and this is negative pi, and this is positive pi. And that seems to be where you set the limits on the joints. That seemed to work for me, with things orientated in that direction. Is that your experience?
Wait,
Yeah. Does it matter if you rotate them? Like if I had them this way?
But Brian, it didn't work then.
What's that?
That's not the result you got. When you rotated it in the game, when it went to the left, it went all the way around and hit
That's right.
the original. And
That's because I set it to be negative pi, so it's able to swing all the way around to here.
oh, it's almost
But on
negative
this
half
side,
pi. Yeah.
It's a half pi.
Yeah,
How come it doesn't like try to go inside the object?
Because the collisions, it'll just bounce off, you know, there's a collision on it, so the objects just bounce off each other.
And you don't know why it's happening.
Yeah, I suspect that's something to do with this term I think in physics it's called restitution. And that's the sort of general, there must be some restitution factor you can set on that. I think that's basically how hard bullet physics engine forces the objects to meet that constraint. So for example, one of the things you can do, BGE has a physics gun in it. You know, you can do this. And the physics gun, what it does is it detects the object, it does a ray pass into the scene, and you can pick that object up and it will try and set the velocity of that object. So now there's basically two constraints on it, I guess. It's trying to satisfy the constraint where it keeps setting the velocity, plus it's trying to satisfy the rotational constraint as well. So you can see it's able to go out of the, you know, it's able to not be a hinge anymore, but it will sort of bring it back to being a hinge and make it satisfy the constraint.
Brian, I think your cylinders are broken.
Why?
Because when you drop one on the ground, half of it goes through the floor before you realize something's happening.
Seriously? That's a good one.
I think the technical is 0, you have to do half of it.
No, there's create cylinder. Create cylinder takes.
Oh, sorry, great. No, great capsule. Capsule, yeah.
Oh, you
you're
can
on
blame Kev
that,
for that. I didn't make those.
Yeah,
You're
you
on
let
that
it in.
sphere.
What?
You let it in.
You accept it all as well.
Really? Are you sure it doesn't work?
Yeah, just draw one there and draw it straight up, and when you drop it into the ground, it'll go halfway down before it does anything.
Okay, so let's say the radius. Oh, that just means his rendering, his model is not lining up with the capsule that he's creating. Bullet. That might need a little bit of.
I think it's just, it looks like it's just the circle,
Sure.
the sphere, and then he pulls the edge of it out to make it look like that, but it doesn't, the rigid body doesn't go out as far as that.
Okay, let's try it then.
That's probably why they work.
Yeah.
Maybe vector 3, let me say over 20, 20, and 6.
Yeah.
Dead.
That's absurd.
Oh yeah. Yeah, at some stage I might fix that over Christmas. Right, let's see, there's a capsule. What are the right parameters for that one? Okay. Just create capsule. Okay, don't need to keep current reference to it. I'd say that could be just his model might not align with the capsules. No, that one's
Make a skinnier one.
Sorry?
Make a skinnier one.
Okay.
I think you're
I'm not answering that question.
Your capsule in your game.
There it goes.
Cool. Yeah. Golden capsule.
70%?
Huh?
70%?
I think so. It's a minute. Yeah, sure. Okay, should we take a short break and then we'll come back and talk about, we'll take a look at Gary's mod and we'll actually just go through all the other joints in the constraint. Okay, so yeah, that's the hinge joints. There are other types of joints you can make. In fact, there's a list of them, and I have some examples of the different types here. Oh yeah, sorry, the last thing, the angular motor. So what I did here in the physics factory, on a hinge joint, you can enable what's called an angular motor. An angular motor, let's see, this seems to take 3 parameters. First is the target velocity, and the second is, I think, the maximum amount of force put by. The first is the target velocity. It's how fast. That must be the target velocity in scalar target. Target velocity. That must be the target angular velocity.
Maximum.
Yeah, and then the second is the maximum motor. It must be the maximum torque. Maximum motor impulse, whatever that means. I presume that's the maximum amount of, it must be the maximum amount of torque. Now I wonder if that 10 is 10 radians a second. I wonder if that's the maximum angular velocity. But anyway, you need to maybe just experiment with those numbers and see what happens. Because one of those hinge joints, let's just try a little quick experiment, right? So there's one of the hinge joints specified as 10 and 10 for those values, and the gravity is enabled in this simulation. So when I go and run this guy,
Display the screen speed of.
ah,
Should display the screen speed of the rigid body. Like that, you know, like the rectangle.
oh, good point.
How fast it's going.
Yeah. Yeah. Anyway, you can see that now the car is moving because I've enabled the angular. I wonder what's happening with that back wheel.
You change
But it's the only one, yeah.
Yeah, so I must have done something weird with the last one. I'd say probably I was just screwed around the parameters or something. 0, 0, 0.
Oh, yeah. The last one.
Oh yeah, so that's one of the axes of rotation should be 1, 1. Okay, cool.
So why is it rotating at all?
Because one of them is set to be 0, one of them is the correct axis of rotation. The other one I haven't specified an axis of rotation, so I'm just not sure that the joint is specified correctly.
Probably wasn't turning, it's probably just freaked out.
Yeah, exactly. I think it's just freaking out. I wonder what would happen if I did minus 10. I presume it would go in the opposite direction. Gosh, Ed. So unfortunately, colored object. So there we go. That's the angular motor. That's how you get your things to move by themselves. Another way of doing it is to take those rigid bodies and just here's another thing you can do. So, for example, you can take the wheel and you can apply torque directly to the wheel. So there's the wheel rigid body. What I'll do is comment out this enable angular motor code here. And instead we'll just try this thing. Wheel rigid body, add force. No. Add torque.
Do you only have one handle for a wheel?
What's that?
Do you only have one?
Yeah, actually, again, that's not for very good coding practice, but I just recycled that variable. So now, here's the torque. Next question, what should we apply for torque? Remember, what do you think the torque value should be? It should be a vector, definitely. And what way should it be? What way should it work? Torque is around the axis of rotation, remember that. So the torque should be, because we want it to rotate around the z-axis, don't we? It's kind of z-axis. Let's try something like GLM, colon, vec3.
Wait, no, wouldn't you want it to be around the, not the Z, but the, Y, because it was the Y-axis.
Oh yeah, good point.
Try it.
I'd say one.
You know what? What's that?
Texture on the wheels just so you can see them moving.
That's kind of a bit tricky to do it in 5 seconds kind of thing, or in the lab. Let's try adding it around the z-axis and see what happens. Oh yeah, of course that should be GLM to BT vector. What's the purpose of that call? Can anybody remember? GLM to BT vector. Why do I need it?
It just casts it to a different vector.
Yeah, you got it. Yeah, I mean, if you look at it, it's nothing fancy. I'll just show you.
Could you make a cast override for that easily enough?
Possibly. I don't know. I'm sure there's a C++ way of changing one type to another, but I just wrote a method. So it just takes a V and then returns a BT vector where I take the parameters and pass it into the constructor to the other object. Yeah, I guess you can do casting and things like that as well. It shouldn't. But hopefully that way. The trike. So now I'm adding some torque instead of. So the problem is the torque gets applied in an instant, and then it's. What I really want to do is actually, when I press a key, apply the torque. I can apply lots of torque then. But I wonder if it should be just
Oh, okay, so
around
that.
the y-axis instead. Let me add 1,000 units of torque around the y-axis instead. And let me get rid of the giant penis.
So is that, would that just be applying and then, so torque's not persistent then?
No, exactly. It's the same with force. Remember what we did with the force accumulator when we were doing the force thing? We always reset the force accumulator each frame. So we'll apply it, you know, yeah, we'll just apply it and then it loses it. So where's the capsule? You know what? We probably won't even see this happening. Even if the torque is applied, the thing might spin and then just see if it moves at all.
It's not on the ground.
Yeah.
It's not on the ground when it spawns, so even if it does spin.
I would need to get the reference back to the hinge.
Spin the whole thing.
I can spin the chassis on the key press and see what happens. I think it'd be kind of tricky to do that. You know what? Let's do the other thing, right? Yeah, you can apply torque and you can apply whatever. I'll just show you the rest of the joints, right? Because there's a little sample project here called Physics Game 1. It just shows you the other joints, okay? So first of all, that's set limits on a joint. And then there's some other joints here. There's just various different types of joints that we can look at. The parameters that we take. Okay, so there's an example, I think, of pretty much all the joints in wood. First of all, a slider joint. The slider joint is kind of a weird joint to configure because, yeah, here's how I did the slider joint. Right, so all of this code here is related to the slider joint. The slider joint, if you have these two rigid bodies like this, you can specify a slider joint so that they can move, you know, along that kind of axis, and you specify the axis as well. How you specify the parameters for the slider joint is bizarre, it seems to me. So these are two boxes created. You specify the slider joint by passing in two BT transform objects. So a BT transform object seems to take two parameters. It's the position and the quaternion. Sorry, the position and the quaternion. Yeah, okay, that's it. So create the two boxes, and first of all I set identity. Then I specify the quaternion through this API called set rotation. And if you notice, this is a 90-degree rotation around the y-axis. When you read the actual bullet documentation for the slider joint, it says that you specify the axis along which they can slide by rotating the x-axis of the transform object that you pass in to be the direction around which you want it to slide. There you go. I didn't write it. So in this case here, our x-axis obviously is this direction here. What we need to do is rotate the x-axis so that the x-axis is now the z-axis. So that's why a 90-degree rotation around the y-axis rotates this one up to the z-axis. So that's why I pass in that rotation there. And the position, I don't think really matters, but I think the position should be the anchor points. I don't think it matters for a slider joint. I don't think the position matters because I didn't even bother setting the position and it seems to work fine.
Is this kind of thing like just like a spring?
It's like a spring without any springiness. They can just slide in and out along each other, right? So that's that one. That's how you do that one, and that's the example of it. What other ones? The hinge joint. Actually, you know what? That's the only ones I made. The other one you can make is called a fixed joint. The fixed joint basically just keeps two objects in the same relative positions to each other. I think I did do an example of a fixed joint. So, I might have commented it out, but yeah, fixed joint is really simple. It's just keeps the objects in the same relative positions to each other. You know, it's kind of easier to look at these in something like this in Gary's mod. So anyway, there's various different types of joints created. There's some joints with an angular motor. That's just a couple of little things, and then an angular motor attached to it. There's constant torque being applied to that. This one here is my original, that's my original hinge joint. It's a fixed joint. One of these is the slider joint. Let's see if I can pick up one end of one of the slider joints. Yeah, that's the slider joint. So you see, when I move one guy, the other guy, they all stay in the same orientation relative to each other. That's a slider joint. So they can slide in and out around each other. That's probably just another hinge joint. That is just a... That's just a hinge joint. I can't remember what the axis is there. So yeah, there's slider joints. There's a couple of other joint types as well, which I haven't done examples of. Let's take a look at Gary's mod, right? If you have Gary's mod, you can play it.
Your game class where you got loads of things put in there for spawning things. I was trying to make them happen. I pressed the space bar through ragdoll.
Huh?
I was trying to program.
Oh sure, yeah. So if you look at FPS controller, you can see that when I check it, you can get the space key, it spawns a ragdoll. So you can comment that code out and put it there. Oh, oh here, do you want to see something really cool?
No.
Talking about kinematic objects, I'm going to show you something really cool.
I would never lie. That wasn't a lie, I swear. I swear on the last lie I told.
This is something we do in the second semester. It's one of the things, it's like autonomous agents, steering behaviors for autonomous agents. So I'm making a breathing game with my friend Owen, who's also a lecturer in Angel Street now. And I did a procedural animation for the fish, and I procedurally programmed the vertex buffer for the fish, and the actual flocking behavior is something that we do in the second semester. So it's separation, cohesion, and alignment behaviors. They're AI behaviors for autonomous agents. And I just think they're kind of cool. They look really fish-like, don't they? Huh?
It's pretty visual.
Yeah. Kind of hypnotic. It's just a procedural kind of animation based on the sine wave function. It's kind of, you know, it's the simple thing. Pendulum. It's how pendulum works. But there's a couple of little animations on the fish. What's that?
The fish attack each other.
No, they do behaviors called separation, cohesion, and alignment. And sometimes one behavior takes over from another behavior, so they'll all try and jump together. When they get too close, they push each other apart. Anyway, let's have a look at Gary's mod.
How do they taste?
Who's played Gary's mod before? Awesome.
I do not have it on this computer. I don't have any games on this game in the computer. It's almost like it's old and not very good.
Probably end up with Junior or something like that. That would have been
Amazing.
that far with you.
Oh.
Strike X9.
Where's my mouse?